Hi, welcome to this video on substitution, or the way I like to think about it is simply using the chain rule known from differentiation to help you integrate. So the rule is over here, and if you look carefully, then you can actually see the chain rule still there. The chain rule tells you if you have a chain of functions, g and f, and you differentiate it, then it's the derivative of f in gx times the derivative of g. Now basically what has been done here is integrate both sides, and you get this term there and you get the integral sign over here. So it's really the chain rule. So of course clearly here you have still an integral and here you have somehow an answer. So this could be very useful, but the point is to recognize this sort of shape in your integral. So you have here sort of an inner function gx, and then multiplied, really there's a multiplication here, by its derivative, and then there's an outer function. So what's important if you want to use this rule is that the outer function is that must be a function that you actually can integrate, because in your answer here f pops up, and this g should be nested inside it, right? So the way to see that happening here is that actually the outer function, well, I can give away the clue here already. The outer function is 1 over something, and the nested function is the x to the cube plus 7. It sits inside the fraction in the denominator. And it's even better here, because as you see there's multiplied here by the derivative of g. Well, the derivative of x cubed plus 7 would be 3 times x squared. So it's almost x squared. So as you can see from this shape, we're well on our way to start applying this rule. Later in the video, I will make the connection to substitution in a notation that's maybe more common and that for some of you maybe even more recognizable. But at first I want to show it this way, because this is, I think, the way to understand it. Because looking for these shapes really helps you to recognize situations where this rule is actually useful. So now let's see. I could write this a little bit more differently to highlight this shape with the nested situation and the multiplication with the derivative. So, but maybe I should already notice that my, I hope for a g of x to be this x to the cube plus 7, okay? So then I'm going to take out this x squared to make the shape of the integrand a bit more clear compared to this rule. So you have 1 over x cubed plus 7 times x squared dx. Okay? As I just said, actually x squared is not precisely this derivative. If I look at the derivative of g, then it's 3x squared. So I'm missing out on this factor 3. And that's not a big problem actually. I can fix this. I just throw in a 3 here. But you can say, oh, wait a moment, if I've just multiplied my integrand by 3, then my outcome will be 3 times as large. You're absolutely right. So to keep the equality sign here valid, I have to compensate, so to say, by multiplying by 1 over 3. Okay, hey, so now it has the shape I want. I have my g of x here in the denominator, and I've got my g prime, my derivative, over there. Now what should be my f prime? What's the outer function? Well, if I work in my notebook, I just put my hand on top of it and I see, oh, it's 1 over something. But if I put my hand here on this glass board, of course you still see this term. But to me it helps, and so I can see that this outer function here, f of prime, and as a variable I use the y now. So the outer function is 1 over y. I could have used any variable here. Actually, we're going to substitute the g here later for y, or the g of x. But I've used the variable y because g is a function that takes x to y, you could say, and then f takes y to z, if you want. So that's why I use y. But in my answer, I need f. So I need to find an antiderivative of this function, but fortunately I, and so do you, can find this. It's the ln of the absolute value of y. I forget about the constant now because it's dealt with over there, okay? But you could say, of course, generally there should be a constant there plus a constant. And the nice thing about using the chain rule now like this, or substitution if you want, is that we're already done. So we have this 1/3, and now I just have to plug in the f of the g of x plus a constant. Well, f is ln of y, so it's 1/3 times ln, absolute value. Now plug in g, that is x to the cube, plus 7, close it off, and well, maybe to be sure, put brackets around this, and then say plus a constant. So if you're not sure about your answer, of course, what you could do is you could differentiate this thing. If I differentiate it, well, differentiate the ln, I get 1/x to the cube plus 7. According to the chain rule, no surprise, because it was there, so if you differentiate, there's a chain rule, you get times 3x squared. But the 1/3 takes away the 3x squared, the 3 from 3x squared, and you get x squared exactly. So this is just absolutely good and fine. Now, what's very common also is to actually really substitute something. So, right, we're done here, but let me show a little bit of different notation that's very often used. When I'm at this point, I could also just say, hey, it's a really good idea to substitute this term. So what I'm going to do is introduce a new variable. I'm going to introduce the variable u equals x cubed plus 7. Okay, so I can continue my integral. I go again from there and then onwards, and then I get 1/3 times the integral over 1 over u. Okay. But then I'm still stuck with 3x squared dx. Especially dx is a problem, right? We want to integrate over a u now. So I need to express dx in terms of u. And the way to do that is just to differentiate this term. I get du dx equals 3x squared. And here comes actually a similar thing to what happens there. There comes this situation where you do something which feels a bit wrong, but it's actually allowed. I can multiply both sides with dx to find an expression for du. Du equals 3x squared times dx. Now, we have not talked about the meaning of du and dx, and I'm not going to. You just have to trust me that this is a valid expression, this is a valid step. This is allowed. Okay, so if that's allowed, then I'm super lucky because this term is exactly this term. And so I can replace it, so I get simply this integral. It's wonderful. Now I have an integral, which of course I can do. It's the ln of a u absolute plus a constant. And now, of course, you need to do back substitution. Back subst. Don't forget this in your test. Back substitution, and you get 1/3 times the ln of x to the cube plus 7 plus a constant. And no, fortunately, it's the same answer that we had before. So what did we do? We did actually in two ways the same thing. We did substitution, or using the chain rule, to integrate this sort of function. And the main thing is it's going to be successful if you recognize one function nested inside another and a multiplication by the derivative of this nested function. So look out for that sort of shape and then try either this substitution or this recognizing of g and f prime in your setup. So I wish you success with lots of beautiful substitution and using the chain rule.